centralized logging. The candidate replied with few things. Then I thought like let me just record the session and what exactly would I want, like how this problem could be approached. So let's say if the question is more around like design a centralized logging system for a company that has huge scale, because the scales might vary. So it's fine to assume like okay, what the things like how many services and all of those things that are there. Let's just quickly go over like what the requirements would be, more of a functional requirements. So one, every service should be able to give the logs, or yeah, I'll say like the centralized logging system. Okay, this is something is wrong with my mouse, right? So let's say the functional requirement of the centralized logging is logs from all the services are available and in the order of are visible, right? Logging system that is there. User can do a free text search and all the matching logs are visible, right? Logs are in timestamp order. They are not providing anything else timestamp order, right? So that makes it. These are few of our functional requirements that we'll have from our centralized log system, where you can just like you can see all the logs that are coming in from various services, and then another thing is like user can just search free text, like any text that they want, and then they could see the logs and all of these things. Cool. So these I think are good enough for now. We can add more requirements, but these would cover most of the things for a design system design interview. If I go to the NFRs, one I think the purpose of the centralized logging is to kind of see all the logs, and this will be very helpful in the debugging system or debugging scenarios where things are going wrong. In that case, how quickly you can figure out from the logs. So one I would say like the system is highly available. The second one I would say like this system should be scalable, because the bursty traffic could come in where like there is a based on the patterns or like somewhere in the morning, because it's a centralized logging service which is having all the logs and everything from everywhere. So bursty traffic could come in, and that can help like handle the bursty traffic, because the logs would also scale accordingly, like whatever the traffic is. So this should be scalable. I think the another thing should be the durability, or I think availability or durability, that would take care of it. But these are roughly like the two things that I would say. Again, though there is a logs, I mean the logs are available quickly in the centralized logging, right? It shouldn't be the case like after 10 minutes, 20 minutes, 15 minutes, but maybe like we can maximum 1 minute delay that could be there. It shouldn't be the case where like logs that applications have put in, they're coming after like hours and hours, right? So here, let's say if I kind of quickly do the estimations, because here it will depend a lot more on the 10 to 10 services, 10 log lines. So 100, 10k is already there. So around 10 to the power 6 request, right? These are the lines, log lines that are getting generated, right? Let's say each log line is maybe or like generated per second, right? Which will now if I kind of go and maybe like few bytes, that's are there. So kind of yeah, on an average, let's say the log lines would be around 10 to the power 6 multiplied by 24, 3600, right? So that would be around roughly how much? 10, 2.4, let's say 3, 4, 5, so around 10 to the power 11 log lines, right? Which will be around how much? 10 to the power 6, 7, or like few bytes that are there, like 10 bytes or something, or 100 bytes, or whatever the log size that could be there, or for simplicity just assume like 1 KB per log line. That would kind of result into few petabytes. This could be like, I mean, this you can kind of you can do this basically, like you can do the specific numbers, but here this gives you an idea, like the number of requests log lines that are there, they are quite high. The storage requirements are also quite high. Now if you kind of storing these logs for a year, then it will be like few right here it will be few terabytes, let's say. If it's few terabytes, then for a year storage requirements would be like in TB petabytes, right? For the GDPR compliance and all of those things, where the logs needs to be stored for 5 years, there it will go even further, right? Multiple hundreds of petabyte of log data, right? So this will be like, I mean, this will dictate few of the design decisions that we take. Okay, so let's say this is how the requirement would look like. Now I would kind of try to put a one like similarly, like applications or whatever the services that are there, right? These could be anything. Now what I am thinking of is like these are putting the logs here. So I'll kind of have a kind of agent here on these services. We can figure out, I mean, we'll talk about specific agents, like what do we want to provide here. Agents, these agents are running on the application, and then what I'm going to do is let's say Apache Flink put, or for the simplicity, let's just messages, right? Message queue. We can go into this particular thing. What it is doing is, simple workflow would be something like this. I can push it here, message queue, then there are few workers that I'll have, right? So let's say few workers are there, or call them consumers through it, and then basically like what I'm doing is I'm kind of thinking of putting them for now, putting them in the Elasticsearch. Okay, let's say yes, and then this is my ingest. This becomes my ingest workflow, and kind of what I'll do is, maybe let's say here let me just move it here down somewhere. And that's kind of what's happening. Okay, so what I'm thinking of is this is going, here is a load balancer. This is, let's say, my, ignore this part, let me just use my, yeah, so this is my load balancer, LP, right? In front of this it could be the some app or browser, whatever that is there, right? Either So there is a load balancer. There are these API servers that are fetching the data from, let's say, the log API gateway. Okay, so this is there now, and that is fetching from the Elasticsearch. Other thing that I could do is basically like, right, instead of having everything kind of putting it in the Elasticsearch, I'll kind of start. So here, secondary, sorry, indexing is done. They're holding the recent data, maybe last 7 days or something, right? Or something. And this is backed by S3, so that I could kind of keep uh, colder tier of data, colder tiers, cold tiers for storing older logs. Right, I can even do the archival and all of those things. We'll go into that. Here, so what's happening here is like these agents, this workflow. If I come here, so my logs are getting pushed from here. Here I could do like both search as well as the get query, like the list query. These are my APIs that are there, like the search API. How it will be served is like it will kind of go to the load balancer, a log API gateway, and it will fetch the data from the Elasticsearch. Indexing is done, and it will kind of try to fetch the data. Here these consumers are pushing the data, so this kind of takes care of both the use cases, right? Now let's do a deep dive a little bit here. So like, what are these agents, right? So there are here like these agents are reading the logs and sending to the message queue, right? Another thing, like few of the thing that it could do is like agents are processing the logs on the machines itself. Like if you want some kind of filtering or some kind of massaging of logs and all of those things, massaging, or maybe like enriching the logs with the machine metadata and all of those things, right? These agents are nothing but, let's say, the earlier, like these agents could be, let me just write it here, agents. This could be like Fluentd or Fluentbit. The other example is Logstress also, but the thing is like this is not very performant, and kind of every service, I mean it might affect the service also. So the what do you say, simpler, or like the lighter Fluentd and Fluentbit are the lighter ones, right? But this is working running on the machines itself, where it is sending the messages to the message queue. This could be maybe like Apache Flink, right? Because the reason the scale would be very high, and what we can kind of do here is like this Apache Flink. Yeah, so this is Apache Flink, and what we'll do is this is partitioned on, maybe let's say, the machine identifier. So that way, like it will create the topics for each machine, or right, which is topics for each machine, right? Or maybe like we can go a step further, where partitioning is done on the machine ID, but the topics could be maybe the log names or something, right? Again, like machine ID and the log. If we want simpler ones, these consumers, like, as because we have partitioned it, these consumers, like, they are reading one I mean, the Flink makes sure that message is getting read once, at least one, like exactly once. So those requirements are there. Another thing that it can do is kind of, so here event stream, like partitions are there, so there are like multiple consumers that are there. Now we have the partitions for each machine, so those many workers we can spin up, and the workers would handle the messages coming from everything. And then there could be like some extra enrichment if we want to put, maybe like in the log structure it will be like maybe like the extra thing, machine ID, namespaces, like if we are bringing it from the pod name and all of those things, error type or the log type and all of those things, right? So that can help us in further, and then it kind of creates indexes, right? Let me just kind of write it, push to es and make indexes, right? This is there. So if you look at it, the agents which are running here, that is one way. There could be other solutions also here. If the what happens is whenever a new service is coming up, the agents like services are having the agents with them agents. Let's say here we call it a fluentd with them. Basically, they are getting deployed with the agents. That's one approach. Or the second approach could be where, like, if we don't want these services, which is slightly difficult because that it might not be the real time logging that, but maybe like some other things could be explored, like rsyslog and all of those things. Rsyslog pushing on each machine, forwarding the logs to central place, right? Central place. Here it could be again like rsyslog. In that case, it will just put the log stress here, and it will try to push into the Elasticsearch. Elasticsearch we are using to support the search use case, right? I'm not going into the details of this, but it will create the indexes, like whatever the text that has come in. We can define like multiple indexes. First that I'm thinking of is just like the text that is coming, like the error message that is there. That could be one. The few other indexes that we might keep is probably like with the service to error, or like more on the error types, like if there is an error or a trace or something, like all the log types and stuff, those kind of things we can create. S3, because the data is very huge, if we can't keep like everything in the Elasticsearch, because our indexes would kind of keep on growing. And anyway, like the log data is more on the append only, and it's the recency data that kind of helps us. So we can put either through the Flink, we can start dumping it into the S3, or like via the Elasticsearch, where the cold storage or cold tier data is kind of getting stored here. Okay, so I think this gives you better idea. Now there are like depending on, if you kind of just talk about the agents, message queue, workers, and putting it in smaller details without even S3. For the junior level candidates, I think this should be fine. But if you are more of a senior candidate than staff or senior, in that case there are a couple of areas where you can go slightly deeper. One would be your these agents, how like these agents could work. There could be like multiple approaches here, and here these agents make sure that they are not heavyweight and affecting the services memory, or as lightweight as possible, and you are moving lot of the processing to the central place. It's just kind of taking it up and forwarding with some extra like very minimal data. That could be one area for deep dive. The second one could be here, the way I talked about the partitioning and all of those things. How would you partition, and what Apache Flink would kind of help you with. Like Apache Flink has kind of checkpointing and all of those things also, so that it makes sure that nothing is breaking. Checkpointing, or it can dump it in the checkpointing of the messages and what has been processed and all of those things. And as we have kind of said like should be 1 minute delay. So here we can, on the Apache Flink, there are ways you can kind of define the intervals in which it kind of dumps the data right into the Elasticsearch and all of those things. So like these consumers, how they are reading it, that could be there, like message. Yeah, let's say the message queue. I mean, here you have the streams, and these basically your consumers. I mean, here you are using the Apache Flink, which kind of help you put it in the, like you can define the intervals for the dumping the data, and that would help you, like though the delay is 1 minute, we have defined let's say the interval of 1 minute, but it will kind of keep on doing the in between dumps also into the Elasticsearch, so that your data would be available. The delay could be 1 minute, but the data might be available, some of the data might be available much earlier. Right, so this becomes more of a stream processing. I mean, we have utilized the stream processing approach here. This one is quite easier, but one thing that you can highlight is, which will show you like more from engineering manager's point of view and whatnot. There are tools which actually provide all of this, where you don't have to build anything from scratch, like tools like Kibana, that is there, which has a direct connection with Elasticsearch, so it will come out of box. You don't have to build all of those things, just configure it, and once your data is getting ingested into the Elasticsearch, this will be there. And these are available on every cloud, like Elasticsearch on AWS is OpenSearch, yeah, and then S3 is there, Kibana is also there. Here you can use Flink, SQS or anything. These kind of agents are also standard now, like Fluent Bit is from Elastic, or Fluent is there. Yeah, so those could be used. So those are few areas where you can deep dive and show your skills, what makes you better for you say what makes you better as a staff engineer. So that's all I would say. Great, I think this covers everything. The DPR, we can move it to the cold storage and everything. Yeah, so that's the basic detail. I hope like this, if you kind of follow this kind of format, then it will be much easier, or like the interviewer would be quite impressed with you.